Welcome home.
Thank you all so much for being here. This is amazing turnout. I'm honored to be the first speaker in the speaker series. Yeah, I'm an ecological landscape designer. I think Britton covered most of all the key things here. That's actually a photo of the rain garden that Rachel and I designed and installed as part of the rain garden design build course here, June 2022, so last summer. And you can see with the new dorm building, it captures all of the roof runoff as well as some of the runoff coming off the lawn and that upper slope, and is directed into these basins. But we'll get into more about how that is sited and sized and planted and all of that tonight. We have a wide range of backgrounds and interests here in rain gardens. So this will just kind of be an introduction on rain gardens and some design considerations. A lot of this is materials taken from the rain garden design course that Rachel and I taught here. But if you want to go a little bit deeper, I'd be happy to chat afterwards or share more information later on some of the more technical aspects in my experience. So let's get into it here. Let's see. Oh, there we go. Okay, just click the mouse. So tonight we will, I guess that'll stay, that top bar.
Might go if you just look at the first one.
Yeah. Okay, well, anyway, the flow of tonight is why do we need green infrastructure? And I start with the term green infrastructure, but that is a huge umbrella term for basically everything that is not like in the built environment, or it's not gray, it's not built out of concrete or wood or impervious surfaces. So green can also encompass like public parks and wooded areas within towns, places that have soils and plants and are soaking up water and providing a lot of benefits and ecological functions. And then we'll get into more of like the rain garden and how it works, what are the benefits, what it does, and then getting into some more design considerations for siting, sizing, planting, and maintain. We probably won't get into maintaining today. We'll see how far we get tonight. This is a rain garden. I helped to develop the plant design and install the plantings with Eco Solutions, who did the whole design of the rain garden, but it's a whole bioretention system that captures runoff right on the waterfront on Lake Champlain from a whole condo complex there. That was a cool project. And we kind of integrated some seating in the area because of limited space. So why do we need green infrastructure, and also why do we need rain gardens? We have seen a big expansion of development you can see obviously Burlington South End a little bit more densely developed than out here, but in the Mad River Valley we are also seeing more development, and it's a lot steeper slopes. It's a mountainous area, a lot of big mountains and valleys, and so there is a lot more impact when there is development, that the water can pick up more velocity and have more erosive force from that water that is flowing off these new development, these houses, roofs, driveways, all of that. So you can see from 1872 to 2009, there is a lot more impervious surfaces over that whole landscape and in a lot of places in Vermont. So this pre-development landscape, there is a lot of natural topography. There are lumps and bumps, and there's tons of roots and trees and wooded areas and wetlands and all these parts of a landscape that help to capture water and help it soak into the ground. And so there's just a lot more places and ways for water to kind of naturally flow through this landscape. And there's not a lot of runoff. So you move into the more developed landscape and there's a lot of impervious surfaces. Things are flattened out and graded so that there's not as much natural topography to stop and slow the flow of water. And then we've also straightened out streams and filled in wetlands and all of that kind of thing that kind of squeezes the hydrological cycle into these more like straightened and minimized areas where it's causing things to flood more. There's not as much floodplain access for water to reach its floodplains and spread out, and it's kind of channeled and conveyed in a more direct way that causes more erosion and impacts the health of our streams and our lakes more severely. So with green infrastructure, we are trying to mimic what is happening here hydrologically by, as Britton said, capturing water as close to the source as possible from where the rain falls or snow melts. And in order to offset all the impervious surface and changes to the landscape that we have made over here. And so that is the main goal of a lot of these green stormwater infrastructure practices. Stormwater being either that rainfall or snow melt that is washing over the landscape and not getting soaked in. Let's see. Okay, click on the left side of the mouse. So as I said, and these are some photos of that impact of increased impervious surface, which leads to a lot more stormwater runoff. And we're seeing a lot more flooded rivers, as we saw intensely this summer. And with, as you can imagine, all this excess water kind of washing over the landscape, washing across our driveways, our roads, our parking lots, it is also picking up everything that is on there. So there's a lot of sediment, there's salt from being spread in the winter. There is dog poop, there are maybe fertilizers, all this stuff that is on our landscape is getting washed into our rivers. And it's also increasing peak flows of rivers. So all of a sudden there's a huge deluge and it is rushing into the rivers, which causes the stream banks to erode more. And so that's pulling even more sediment down the river and eventually ending up in our lakes. So this is leading to sedimentation of our lakes, increased just soil, and also over nutrification. So all these excess nutrients of phosphorus and nitrogen. The phosphorus is a big concern in Lake Champlain because it leads to cyanobacteria blooms. That is kind of the limiting nutrient. So when there's a lot of phosphorus being washed into the lake, the blue-green algae or the cyanobacteria grows in excess and leads to basically this kind of like anaerobic environment, kills a lot of fish, collapses a lot of underwater ecosystems. And so we are also seeing that increase with more extreme rain events happening more regularly. You can see that very visually, the Otter Creek flowing into Lake Champlain, dropping all those sediments. That was in the, I think, spring floods of 2011. So this image shows that as the impervious surfaces increase on a landscape, the stormwater runoff increases, moving from like 10% runoff in a forested, like naturally vegetated pre-development landscape up to like 55% runoff. And that's in an area that's very urban where 75 to 100% is impervious surface. But even, let's see. So you can double the runoff, even just with 10 to 20% impervious surface. that can increase the runoff to about 20%. So, and so peak flow is more erosion. It also decreases water quality and stream and lake health. I touched on a few of these things, but sediment from our driveways, from our roads, a lot of nutrients from just washing off the landscape, especially coming like from fertilizers and things like that. And then a lot of bacteria from sewage or other sources, oil, grease from cars, and there can also be heavy metals and toxic liquids in our landscapes. So that is what is happening. And so it is interesting too to look at the impact that developed lands have. And so developed lands being like houses and roads and town centers and all suburban areas. You can see here, this is from the Lake Champlain Basin State of the Lake report. So developed lands in the orange here, and we have about 4% of the watershed, land area in the watershed of Lake Champlain, but contributes to 16% of the annual phosphorus load. And so you can see the metric tons of phosphorus per square mile, and developed lands has much more highly concentrated phosphorus runoff than even like our agricultural lands, almost exactly double that. So they're small areas, but they have a lot of impact. And the more that we can capture and treat all stormwater runoff from our developed areas, that includes our houses, our driveways, the more we can create sustainable sites. And so capturing and treating as close to the source as possible is really important. So our conventional, to just give you kind of what to compare the green stormwater infrastructure to, our conventional stormwater infrastructure are our ditches, our culverts, our drains, our pipes, everything that captures and conveys stormwater runoff and prioritizes the expedient removal. So getting it away from our roads, our houses, and typically without much treatment. And this is good. You know, we need this to make sure our roads don't flood and our houses are, you know, water staying out of our basements, and we're keeping our bridges open and all of that. But we also want to, with green infrastructure, we want to prevent the amount of water that's getting to these systems in the first place. So the more that we can capture and treat water runoff higher up in the landscape, up the stream, then the less impact this infrastructure will see, as we have seen so acutely this year in 2011. We want to minimize the deluge that these systems are seeing and being tested very extremely. So yeah, so kind of working with our conventional stormwater infrastructure and minimizing the impact and destruction of those systems as well. Oops. So what does green infrastructure do? As I said, it attempts to mimic the natural hydrology of pre-development landscapes, and it creates sinks in the landscape. So you can kind of think about in the watershed that starts from headwaters down to the lake at the bottom. And right now, a lot of phosphorus and other nutrients. Phosphorus, again, is like kind of a focus with Lake Champlain, but you can think of all the other pollutants that are coming off our landscape, washing all the way down. And the more that we can create little sinks in the landscape to capture and hold those nutrients higher up, and maybe, you know, use them for plant growth and other things that can use them constructively, then that's the better we can be doing. So it reduces impervious surface, it can reduce runoff volume and rates, flooding, erosion, all the pollutant loads we're seeing in lakes, and it increases infiltration, water soaking into the ground. It helps to recharge our groundwater. So because we're seeing so much more runoff, our groundwater can sometimes get pretty low, the groundwater levels. And so we want to recharge that groundwater that's, you know, our eventually turning into the drinking water we pump up in from our wells. And then it also increases evapotranspiration, biodiversity, and sometimes water reuse as well. So some of the best things you can do are just the most basic and sometimes most effective green infrastructure is the trees and the naturalized vegetation in our landscape. So planting and protecting native trees, shrubs, understory, the natural and uneven ground, leaving the duff, so the woody debris, the leaf litter, the dead plant material, all this stuff intercepts water that flows over the landscape and helps it soak into the ground, or so plants will soak it up. This really comes into play with new construction projects or renovations or redevelopment projects. And so the more that you can kind of preserve the natural topography, maybe avoid regrading the whole site, fencing off big trees to protect them as much as possible is really good. And then lawns also, if there's, you know, big expanses of lawns, and maybe we'll get into rain gardens and how we can integrate those into existing sites. But if you can reduce mowing or do no mow zones, returning them to natural successional vegetation that, you know, that they will turn into whatever the land wants to be in that place, then or mow where you go. So maybe just reducing your lawn and mowing pathways through a more naturalized meadow zone. This is used to be a lawn area at my house, and we just stopped mowing it. We planted some fruit trees in there, and we just mow pathways through, and we've seen a huge, I haven't seeded anything in there, but we've seen just a lot of comeback of asters and echinaceas and goldenrod and so many cool things. So there's a lot just out there in the soil and in the wind that native seeds will find their way and come to your no-mow eventually. There is some, you want to be careful with invasives and make sure that those also invasive species don't just take over if you stop mowing. So I can talk more about that if you'd like to after. So yeah, we'll kind of skip over more of this, but around waterways is really key by renaturalizing vegetation, the buffers between developed areas and streams or rivers, lakes. And so the more naturalized vegetation you can establish between your home or your driveway, roads, and our waterways, the better. So this is the Vermont Guide to Stormwater Management for Homeowners has some really good resources on how to select the right green infrastructure practices for your home or your project. If you have gutters, rain barrels can be a great way to capture that runoff and reuse it in your home landscape. Or you can disconnect the gutter downspout to a vegetated area for some passive watering. A dry well, if you have a lot of water runoff and you're having erosion issues like near your house, a dry well is basically it's essentially like a cylindrical basin in the ground full of rocks. So it can fill up with water, and then there's holes, so it'll percolate out into the surrounding native soils, and it's all buried. And so that's good if you have like a really small space and you don't really have room for a rain garden. You can still infiltrate the water, recharge groundwater, and that is a good small practice. If you don't have any gutters, a drip edge infiltration trench can be great. Basically a trench where the bottom is angled away from your house, and then fill it up with gravel or pea stone or some sort of round river rock. And that just helps a little bit more capacity for the water to soak into the ground and then flow away from your house. And so then runoff from your house, your driveway, or your road, rain gardens are a great solution to capture runoff and let it spread out, be full of native plants, and soak into the ground. Vegetated swales are also a great way to do this, and they can be combined. So maybe like a swale conveys water and deposits it into a rain garden. If it's a steep slope, you may need some check dams, basically kind of rock barriers that are installed every so often down the swale to slow down the water so that it doesn't pick up force and cause erosion. And filter berms are another interesting practice I don't have a lot of experience with, but have a lot of potential. And then also some of the best things you can do if you can is just reduce impervious surfaces, maybe install pervious pavers instead of pavement, or like there's a lot of geogrid, kind of these like hard plastic structures that you can fill with pea stone instead of like a pervious concrete walkway. So let's get into the rain gardens. This is a rain garden we installed this summer at C.P. Smith Elementary School in the New North End of Burlington. And so what a rain garden does, and a lot of the green infrastructure, green stormwater infrastructure, is, Brandon, you kind of touched on a lot of these things, but it captures the water, it slows it down and spreads it out. Kind of similar to like what a floodplain does. And this helps to reduce peak flows of runoff. It helps to prevent erosion downstream. And then it sinks the water into the ground. So it filters out the pollutants with that soil, with the plant roots, plants soaking up the water. And then you can reuse it in the water in the landscape. In the case of a rain garden, you're just kind of using the water as passive irrigation, reusing maybe more in the form of like rain barrels or something like that. And then you're also protecting the water quality downstream. So there's a ton of co-benefits to rain gardens as well. So, you know, unlike a dry well, which is buried, it still has that infiltration capacity. But a rain garden that is planted with native plants, there provides habitat for pollinators, birds, amphibians, and a lot of other wildlife. It also creates opportunities to have more shade, sequester carbon, regulate temperatures, especially in those highly developed urban areas where there's a lot of concrete, and soaks up that heat of the sun. And then just the benefits of having beautiful spaces, educational opportunities for kids, and connection to our water cycle, to our watershed, to our, you know, understanding how we're connected in the watershed and to our lakes. So this was the same rain garden at C.P. Smith Elementary, all the kids running around and playing in the rain garden. It's really cool. So this image is from the rain garden manual for Vermont and the Lake Champlain Basin. If you're interested in learning more about this, this is a really great research source that was just produced or reproduced. There's an older version too, which is also a great resource and actually has a much more extensive plant list. But this is a really great updated version. And so this is a basic rain garden. Essentially, it's just a depressed area in the landscape that is planted, that is designed to capture and absorb stormwater. It can come in a lot of different sizes and forms. It can be super small, it can be super simple. And you'll hear it be called a rain garden, a bioretention basin. There's vegetated swales or bioretention cells or tree cells, all essentially different terms for the same concept of capturing stormwater runoff, holding it, sinking it into the ground. So bioretention is pretty much the same thing as a rain garden, except for that we'll usually always have an amended soil or filter media. So sand will likely be brought in, or pea stone, to create more water retention capacity and also increase infiltration rates of the area. But pretty interchangeable, bioretention basin, rain garden. This soil medium mix, so you can see here, it's shown as the filter bed. That is usually a 70-30 mix of sand and then topsoil and maybe some low phosphorus compost, ideally. And I'll get into that a little bit more later. But 70% sand, 30% topsoil, and some organic matter. You probably want at least like 5 to 10% organic matter. And that just increases infiltration rates and water retention capacity of the bioretention or the rain garden basin. So you can see you'll have, this one has under or a drain inlet. This could be coming from a gutter downspout, or it could be coming from just like a drainage pipe. And so the water is then inletting into the rain garden. You often want to have stone or something that will help to dissipate the flow of that water flowing into the garden and to help prevent erosion happening within the garden. And then it fills out this whole basin area, fills up with water. So this is the ponding area. Usually want that to be 6 to 12 inches deep. And then that is where all your plants are. The water will slowly percolate down through the, the top layer, like wood chips, could be pea stone, or ideally maybe just a green vegetative ground cover. Water percolates down through. As it does, sediments are settling, nutrients are being soaked up, absorbed, and other things are being filtered out through various processes in the plants and the roots and the soil. And then if they're, typically rain gardens are designed to have an overflow, so if too much water rushes in for the capacity of the ponding area to contain, there'll be a designated overflow area at the level that you want. So there's like a rockline overflow here to prevent erosion, and the outflow will go into ideally a stable, maybe vegetated area. Some rain gardens and bioretention basins have under drains, and so that would be a perforated pipe along the bottom of the basin underneath the filter media mix, and either water will flow down through the basin, and then once it hits the bottom and it starts to kind of fill up from the bottom, it will go into holes in the under drain and out. Or sometimes there'll be an upturned pipe where once it hits a certain level in the ponding area, it'll flow into a pipe and then flow outward. And that is if a rain garden is connected to like a storm sewer, or it is usually in more urban areas, but it also can be used if there's a lot of clay soils and a low infiltration rate in the natural native soils, or if there's like a really high water table. But anyway, we'll move on here. And so in the rain garden, that pollutant filtration is happening through a variety of processes. The soils, the filter medium mix, so a mix of sand and organic matter and topsoil, the plants, the roots, microorganisms, mycorrhizae. There's a lot of things that are happening that we don't even fully maybe understand, but it's filtering out a lot of the sediments and pollutants from this stormwater runoff. So there's a physical settling of suspended solids. So the runoff catches a lot of soils, grains of sand and clay and silt. Those are physically settling in the garden. There's the biological filtration. So plants are uptaking pollutants and they're evapotranspirating. And then there's also a physiochemical element where there's actually plant absorption of phosphorus, nutrients, heavy metals happening in the garden. And so that's how the runoff, and the level of water filtration varies from garden to garden. There can be kind of a wide range of this, and it's still being really actively studied. Typically, sediments, bacteria have really high rates of being removed from the water. There's more variety in the nutrients, and this can depend on a lot of different elements, but essentially one of the big culprits of it actually is adding too much compost to your rain garden, which is actually introducing more nutrients to the system. And so that's why we try to limit the amount of compost used and not introduce more nutrients into our system. This is a sign I designed for a rain garden in Montpelier. It's at the VSECU bank, and it's a cool one to go check out. And you can see that process of, so just in 1 inch of a rainstorm, the first inch of water falling, 5,000 gallons of water flow into this rain garden. There's an pre-treatment sorbet. I'll get into that a little bit more, but it helps to capture your water in an initial little basin or cell, and that helps to settle out a lot of the sediments. There can be a lot of oily, greasy, silty stuff in that initial runoff, that if you can help it to settle before it gets into the main garden basin, it helps to prevent plants from getting covered in all that mucky, greasy, oily material. I've also seen this happen where a rain garden will fill up with water after a storm, and then because of all that silty, greasy, oily stuff that flows off of parking lots and other places, it can kind of create this seal in the rain garden, and you actually have to like poke holes so that the water can drain. Eventually you need to scoop out all that sedimenty, oily stuff so that the rain garden can go back to functioning properly. Anyway, so that sorbet settles a lot of the sediments and stuff in the water, and then once it fills up, it flows over into the main planted basin. It spreads out, and the plants take up water back to transport by remediate by removing, degrading, stabilizing pollutants. And then this one, actually this would have been a better image to show it on, but this one has an under drain. And so they actually did a vertical under drain here where the water flows down. Once it kind of reaches its infiltration capacity in the native soils below the basin, the water will start to rise up. It'll hit this under drain, the perforations go into the under drain, and then that is connected to the storm sewer, the nearby catch basin, and into the storm sewer. So that is once the native soils can't hold any more water, that's where that under drain comes into key play and pulls that overflow of water. It's filtered though, so it's a lot cleaner than it was when it first washed off the parking lot. A little zoomed in version. Oops. Okay. So my favorite part, and I think the bread and butter of the rain garden, are the plants. And I feel like the native plants create a lot of the benefits that are happening in the rain garden. You know, just like you'll see sometimes basins will just be mown lawn, and those are still capturing and infiltrating water, but they might not have as many of the filtration benefits and also the pollutant uptake that plants provide, nutrient uptake, as well as the habitat creation that plants provide. And so in addition to those biological and physiochemical water filtration benefits of plants, plants also increase the soil tilth. And so that's like kind of, you can think of it as like the fluffiness of the soil by creating really healthy aggregates or like chunks of soil, increasing aeration. So I've worked on a project where we built a rain garden, and it was in a really compacted area. And even though we dug out the basin, the soil below was still super compacted because it used to, you know, vehicles used to be driving over it all the time. It was kind of on the edge of a parking lot. And so there was not much we could do. We tried to aerate the soil as much as we could, apart from, you know, digging the whole subgrade out and removing it, which is pretty intensive. So, but with the plant roots are actually reversing compaction that is happening in the soil from, you know, vehicles running over soil and compressing it down. And so the roots reaching down into the ground, they increase aeration, they bring water deeper down into the subsoil, And they also actually increase the infiltration or water retention capacity of a rain garden. So they create more capacity to hold more water beyond just the soil and having like a basin. You can see this is an illustration that's in the Vermont Bioengineering manual that I drew. And so you can see how deep native plant roots go. I chose, well, it probably would have been a little nicer and chose some other non-natives that have slightly deeper roots, but like we see daylilies a lot, and hostas or turf grass, all non-native plants have a pretty shallow roots. And then these are all native plants, some grasses like the switchgrass and the big blue stem coming down to like 9-10 feet deep where the roots are reaching way down into the subsoil. That I think is a dogwood, no, that might be a button bush over there, having more woody roots that might grow a little bit more laterally. But it's good to have a combination of more fibrous roots. So from herbaceous perennials, grasses, flowers have a lot of little tiny fibrous roots filling up the space of the soil, and then the strength of more woody roots. So that like tensile strength of a woody root really helps to stabilize and break up compacted soils. So there's a lot of things that plants do. They also add organic matter, so that growing, dying cycle that happens with plants. It adds leaf litter, dead plant material, and it builds up that soil tilth. It builds up fertility of the soil, holds more water, increases just the biodiversity of microbial biomes and all that good stuff. Also, I already touched on that, reversing compaction, and then providing a lot of habitat for pollinators and other wildlife. So we'll get into a little bit, I guess, does anyone have any questions so far?
I'm a little bit curious about some of the maintenance that you were talking about that needs to take place in terms of piling up, and if any of that can be minimized with like before construction.
Yeah, yeah, I would, because I don't know if we'll get into too much maintenance, so we can talk about that a little bit right now, but you kind of touched on one of the key features to help reduce maintenance is that pre-treatment forebay. Eventually rain gardens, so you have to continually be removing sediment that fills up a rain garden and kind of can choke out plants, and also create that seal like I was talking about that reduces infiltration capacity. So that pre-treatment forebay is great because I mean, it's a lot easier to shovel out a little rock-lined basin than a whole big rain garden full of plants. That gets a little bit more tedious and hard to do. So that's one way to do it. And other maintenance, the main thing is you do want to cut back plantings in the fall. So typically with gardens, ecological maintenance, I encourage people to not cut back in the fall, leave dead plant material through the winter to provide all that habitat for insects and seeds for birds and all that good stuff. But because the plants can take up a lot of heavy metals, also depends where the rain garden is sited. So let's just say it's in a big parking lot, the one in Waitsfield, right in the mid-Hurons there. That one fills up. That's actually the one I was thinking of that filled up with so much silt and oily, greasy material from cars that it sealed up. So that one has to be like shoveled out pretty regularly to keep that infiltration going. Those plants can also suck up a lot of nutrients and heavy metals. And so when herbaceous plants die in the winter and just, fall back to the ground, they senesce and they'll actually reintroduce those nutrients back into the rain garden. So, and the heavy metals, because they're kind of going back into the garden, decomposing, and then those are all kind of being reintroduced back into the garden. So it's good to cut back all the herbaceous vegetation in the fall And so you're actually pulling out, you know, whatever the plants soaked up or uptook with heavy metals and nutrients, and putting it in a place, ideally in a place where they can just decompose and not be washed into a nearby waterway. So like, you know, some sources recommend bringing it to the landfill. I feel like that's only in a place where, you know, there's like really intensive heavy metals in that spot that plants might be uptaking. But yeah, I think if you can find just a place that to let them decompose and return to the soil in a place where they won't get washed into a nearby waterway. So that is a quick, those are probably like two important things on maintenance. Anything else you had in mind?
What was the word you used, when things die and return back into the soil?
Oh, senescence. Yeah, just kind of like that, like the aging, the dying of the plants, and then reintroducing whatever they took back into the soil. SENESCENCE, I think. Senescence.
To follow up on that, have you seen this, like, we hear on parcel, totally impervious surface. And I remember like years ago when my professor was talking about like the Randolph parking ride being paved in like a slightly impervious surface.
Mhm.
Hardscape, so cars can park, whatever, but it still allows rainwater to penetrate through that hardscape surface.
Mhm.
Have you seen that type of application be helpful, or does it still come with its own set of issues in terms of?
Yeah, I think. Oh yeah, thank you. Sorry. So the question was about impervious pavers or pervious pavers, or was it like a pervious pavement?
It was a pervious pavement.
Pavement, yeah, in a parking lot instead of like your conventional impervious pavement. So I think they can work well in the right application. A big issue I've seen with those is that they don't work well after they've filled up with like sediment. And so I think you need to have, if your town or city has like the municipal vacuum, it's like a big truck, what is it called? Does anyone know? Does anyone know what I'm talking about? Yeah, sewer vac. Yeah, it's like a sewer vac. So it's like a street sweeper, or, you know, it's a big municipal truck, sewer vac, similar idea. So that's the best maintenance of those, like a porous pavement or pervious pavement. So you need to vacuum it up very often, or else it can get clogged and prevent that infiltration from happening. And that has to happen pretty regularly, especially in Vermont, where there's dirt roads and sediments coming from all over the place. In a place where there's less sediment being like introduced to the system, or, you know, there's not road salts being dumped on it, I think it can work. Or if you have like reliable, regular vacuuming of the area. Yeah. But yeah, that's what I've learned. Did it seem to work in that location?
I don't know, so I'm wondering if it's something that's like worth checking or looking into. Like, I don't, you know, there's a lot of, like anything, there's always like greenwashing parts where you think that you're doing the right thing, but really it's the same.
Mm-hmm.
So
yeah.
I was wondering if that's like doing some sort of weird off-gassing or bringing everything that was going on.
Yeah, I feel like I've maybe heard it work as like in the sidewalk application more successfully, just because cars carry so much debris and grease and oil and carrying sediments that it can help, you know, easily clog up things like that.
So it's pervious until it's not being taken.
Yeah, or just, well, lesser, probably lower infiltration rates. but I mean, I'm sure there are situations where it has worked really well, and so I don't want to like, yeah, prevent you from going down that road. I think it's a good thing to look into. But I think, yeah, the maintenance is key. And for some bigger cities that have those like sewer vac trucks like that, it's a great application as long as they have that maintenance plan integrated into the project. Okay, yeah.
One quick question, with that you've seen in the past with your rain gardens and the like pre-treatment surveys in the parking lots. Have you ever seen them get destroyed by the, snow maintenance, snowplow? And how would you prevent that from happening?
Yeah, that's a really good question. So ideally the goal, and this either has to be like a design consideration in siting the rain garden in a place where a snowplow won't dump a bunch of snow on it, or coordinating with the snowplow person to make sure that they aren't dumping a bunch of snow on the rain garden. But ideally, yeah, snow is not being dumped directly onto the rain garden. I mean, it's not, a rain garden can still work, and it's actually maybe not the worst place for snow to be dumped as well, because there's a lot of dirt and like salt in that snow. So, you kind of actually want it to go into the rain garden to be filtered out, but it can also kind of clog things up, or it can crush, woody plants maybe, or stuff like that. I think that happens. Like the snowplow blade can wreck forebays or curb cuts or things like that for street side fire attention.
Would you recommend like, some giant boulders in around your forehead so that,
Yeah.
screws up the plow?
Yeah, that's the best way, is like working with the plow's existing infrastructure. So concrete curbs are great to just prevent the plow from going right into the rain garden, or big boulders are great too.
Curb.
Yeah, a curb where there would be, it would slot down so water can still flow in. I think it's like a bit of design and also coordination if possible with the snow removal services. Yeah.
Is that anything you've got experience or information about as winter specific?
Winter specific water catchment. Yes. So salt tolerant plants, especially in Vermont, where we apply a lot of salts to the roads. So definitely need salt tolerant plants. Looking at University of New Hampshire Stormwater Center, I think, has done a lot of research on this, and they have found that even in winter, with no, there is still really good filtering capacities of rain gardens, and especially now we're seeing more like freeze thaw cycles. So, during the thaw, a lot of snow melt runs off and it can soak into the rain garden. If it's just all frozen and iced up, that can kind of block things up for a little while, but with more thaws that we're seeing, they're actually functioning really well in the winter. Yeah.
Yeah, just speaking of that, like you said about working with the plows, we're so used to seeing these mountains of snow in the same places in the same parking lots every year. Doing something about.
Yeah, I don't know. I mean, in terms of moving the snow plowing, or like putting rain gardens in those locations.
Potentially, or creating, design something that, reduces the need for trucking the snow out.
Yeah. Yeah, or maybe, designing a big basin in every corner of parking lot where you dump the snow and it, drops all its salt and grit and that and filters into the ground. Yeah, it definitely has to be considered, especially in these like public parking lot areas. I think I would definitely look into the University of New Hampshire Stormwater Center. They've done a lot of research and definitely know a lot more about that piece than I do. So, all right. So for the last 15 minutes here, so I want to allow some more time for questions at the end. I might skip a couple of slides here, but this is kind of just an intro on some design considerations. We've already touched on a lot of these things too, but siting, sizing, planting, all of that. So siting a rain garden, this is also, a lot of this is geared towards the homeowner or residential site. And so this might not address some of those more urban or public areas. But common sources of runoff are gutter downspouts, driveway runoff, roof runoff, and then lawn and upland runoff. And so I call lawns like semi-impervious because they do soak up a lot of water, some better than others. But say you have like a very compacted lawn or a very steep lawn, you know, the roots are only as deep as however tall the grass is, that's about how tall the roots or how deep the roots are. And so it's not soaking up a ton of water. So you still have more runoff than like your woodland area or your meadow area. And then, so you do want to kind of utilize existing drainage patterns if possible. And a big key thing that often happens is people want to put rain gardens in where like the water is actually ponding. And typically you don't want to do that because it's probably pretty low in the landscape. It also might not have great infiltration rates. It might be kind of clay soil or compacted. And so try to capture and infiltrate runoff upland, like as close to the source as possible, as close to the roof runoff. Maybe instead of siting a rain garden at the bottom of a driveway, you put in a couple water bars and capture it a little bit higher up. That can also prevent loss of your gravel and your road surface material because it's intercepting that flow of water. It's slowing down the velocity, the quantity of water. And so you can prevent erosion and capture and infiltrate runoff a little higher up in the watershed. And then you do want to make sure though you're probably at least 10 feet away from foundations, away from septic, leach fields, wells, maybe more, maybe 50 feet from wells. It depends on the location, but especially like you don't want to plant a willow right next to your septic or well because those are super aggressive roots that will kind of get into your septic drainage field and all that. And then you also want to protect existing tree roots. So ideally not like digging a rain garden right at the base of a tree where you will have to cut into a lot of the roots. Siting, I'm going to kind of gloss over this, but I can, if you're interested, this is kind of more of like detailed DIY if you were to install a rain garden at your own house. Ideally, it's an area with less than 8% slope, but if it is a steeper slope, you can put like internal, like a variety of basins, so kind of like a terraced basin system or check dams or berms within your basin to create for like multiple ponding areas. And then the infiltration rate is important though. You do want about a ½ inch of infiltration per hour. So that means that your rain garden will soak in fully within 24 to 48 hours into the ground. And you can do this easily yourself. We did this with for the rain garden course here. You do a simple percolation test where you dig a hole 1 to 3 feet deep. You fill it with water 3 times and let it fully drain out those 3 times. And then on the third fill up, that's what it is. So on the third fill up, you just want to measure how long it takes to fully drain out. And if it drains within 48 hours, you're good to go. You have a good infiltration rate. And so, yeah, so it's like a 2-foot hole. So 24 inches drains within 48 hours. You have a ½ inch per hour infiltration rate. And so you want to think about seasonal high groundwater tables. You don't want to be so low in the landscape where if you're too close to the high groundwater table, basically you don't want water coming up from the groundwater and filling up your rain garden. Ideally, want to be higher up in the elevation than that. And then if you do have low infiltration rates, so that could be like a lot of clay in your soils, you may need to add that sandy soil filter bed mix. So digging a little bit deeper and then adding some sand, mixing it with a little bit of native soil, and that will just help increase your infiltration rates. And also call dig safe, make sure there's nothing critical under where you're digging. Sizing, so don't worry, we're not going to go, this is like pretty technical if you want to calculate exactly how much runoff is coming off your landscape and how much water you want to treat in your rain garden. You know, ideally a rain garden is treating at least the first inch in a storm event. That is because the first inch is what washes everything off the landscape. So if you can at least capture and treat the first inch, you're capturing a lot of that crap that builds up, the oil, the grease, the sediments, the dog poop, all that kind of stuff. And if you can size the rain garden even bigger to treat the 2-inch storm, right, that's awesome. But a lot of studies have shown that something is better than nothing. So even if it's undersized, it's still doing something. It's filtering at least, you know, all your small storms that are 1/2 inch or less or something like that. It's still better than nothing. And yeah, you want about 6 to 12 inch ponding depth and maybe 1 to 3 feet of that sandy soil filter media mix. And we're gonna keep on moving here. So this is where we kind of get into more of the designing for function and maintenance that we kind of started to get into. So this is getting water into the rain garden. I've seen a lot of scenarios where it's a beautiful rain garden, but there's something happening at the inlet. The curb is a little bit too high, or there's like too much rocks in the way, or it fills up with weeds and sediment where water is not even getting into the rain garden. And so that can be a maintenance thing, you know, regular clean out, making sure leaf litter and debris isn't building up at your inlet and actually preventing water from ever even getting in the rain garden. But you can also design it to work more fluidly, more efficiently. So conveyance, this could be a gutter downspout, extension pipe or drain that like directs your gutter downspout into the rain garden directly. You can see that's what's happening right here. A big swale, so like a gradual grassy swale, can kind of see that at the bottom corner. That's another way to grade the area. Or so maybe you're capturing runoff from a big hill above, and if you create like a gradual grassy swale to kind of slowly direct the water down and into the rain garden. We did a little bit of that up at this rain garden. We did a couple like cross kind of water bars across the field, basically like a trench that was intercepting water that was coming off the hill above and directing it straight into the rain garden, basically a little trench full of stone. And then, so once we get the water into the rain garden with our rock-filled trenches or pipes or downspout extensions, grassy swales, all of that, then we also, once we get the water into the rain garden, we want to dissipate the flow. So it usually comes in concentrated from like a concentrated flow point. And that can create a lot of erosive power if it's a big rain event. And so having rocky inlets like right here, or this is the rain garden in Montpelier at VSCCU. So you can see this pre-treatment forebay. It's kind of a rock line that fills up. Here you can see sediment all settled in the bottom of that. So that'll fill up once the water rises up and reaches the elevation of this next rock line berm. It flows into the rain garden. And so that settles the solids, prevents clogging, Yeah, especially for parking lots and driveways. And, or if you have more sheet flow coming into the rain garden, so say you have more of like a linear rain garden like we did up here, and there's just runoff coming off the hill and it's all flowing into the rain garden, just say like a simple grassy filter strip. It can be lawn to slow and dissipate the flow as it goes into the rain garden, or it can be like a rock lined filter strip. I'll show you an example of that.
Do I see the standpipe in that BSEC one?
Yes. That, I think that's actually just a way to vacuum out that under drain. So that's a good question. Yeah, in some cases that'll be the overflow point, where once the water hits that level, it'll then flow into that pipe and either be taken directly to the storm sewer, so it doesn't ever like get the treatment and filtration of the rain garden, or that is, so this is just like a maintenance feature so they can access the under drain that the water is entering from down below the filter media. Yeah, it's a good example of like, if you see that standpipe in a rain garden, it could be the one or two of those applications. So this is the rain garden at CP Smith Elementary. And this has a couple of those inlets. And so there's grassy swales. You can barely see them because they're very gradual, but they're slightly graded from each side. So all the runoff coming off this parking lot enters through the grass here, and then it's directed down into the rain garden. There's not a lot of runoff coming over here, but if there is, like from the lawn, it's coming down in. And then we have a full rock lined filter strip around the whole garden. So that just helps to prevent erosion at the inlet of the garden, dissipate the flow of water. This is kind of a more concentrated inlet point where water channels up in the parking lot a little bit and then flows in here. So in the grass, you can actually see there's a lot of buildup of sand and sediment. Just even hitting the grass will help to settle a lot of that. Ideally, you know, that gets like scooped up at some point. Eventually, this will probably fill up with more sediment and that'll have to be scooped out and maybe replanted or remulched at one point once it kind of fills up so much that it doesn't have a great infiltration capacity. So let's see. Bowl and berms, you want to have a level bottom so that the water can fully spread out evenly and not get concentrated in one area. You may need that sandy soil filter bed. So this is, I think this is the mix in the Vermont Stormwater Management Manual. So this is, if this was like a permit project and you need to follow the Vermont Stormwater Manual, it's like 85% sand, 10% clay, silt loam, 5% organic matter. Or what I typically use is just roughly a 70-30 mix of sand and the native soils. And then optionally, you can have a rock layer either under your filter mix. Sometimes it's also separated from the sand with like a filter fabric. And so that just helps to keep the gaps in the rock layer open. And so it has more water retention capacity. And so, this is the one in Waitsfield. So my advisor for grad school, Stephanie Hurley, she helped to study and design this one. It's much more overgrown now. It's pretty cool. It's full of asters. The dogwoods are really vigorous out there. But so this one is capturing all the runoff from the Huron's parking lot, or most of the parking lot, and it was so full of silt and grease and oils that it was creating this seal where it wouldn't infiltrate in big rainstorms. And so they redesigned it to create this like internal forebay. Basically, there wasn't like space to have a pre-treatment forebay, and so there are actually these like prefab inlets. They're called rain guardians, and that helps to settle out some solids. It also helps to extra things that are flowing into the rain gardens and that doesn't get into the garden. But once it flows in, it goes into this like non-planted, just open rockland bay. And so that allows the water to fill up, it ponds up, and then it can more easily be shoveled out. So that's a maintenance feature where it just makes it easier to shovel out all the sediment in the middle where there's no plants. And I want to make sure we have enough time for questions. So outlet, we kind of touched on that. It could be like an internal outlet into a drain pipe, or it can just be, this is the one at the elementary school, just to make, it's like a concrete curb. The engineers designed that just to make sure it was at the right elevation so that it wouldn't back flood up into the rain, the parking lot. It would flow back into the lawn. This one is a storm grate, and it was getting all clogged up with mulch, and so they put just a simple like fence barrier around it so that the mulch couldn't clog up the storm grate as it overflowed into the drain. We're just going to keep going here, show you. So, oops, where do we go? Sorry, a little bit of a lag here. Okay. Ideally, there's no bare soil. There's either stone, wood chips, or living ground plant cover. We really want to prevent nutrient leaching or introducing more nutrients into the soil. So if you do use compost, a low phosphorus compost is ideal. So that's a compost that's not manure based or food scrap based. It's like yard waste based, mostly just like leaf litter and yard waste, and then that has a lot less phosphorus in it. And typically when I'm planting a rain garden, I won't apply compost over the whole area. I'll just add a few handfuls as I dig the plants in and just put it directly into the holes. So it's going directly to the roots, just giving the plants a little boost initially. And then native plants shouldn't need too many added nutrients. And so that's really usually all you need. Shape, you can have fun with this, design with the surroundings, the landscape. It does help to delineate and define edges. I've found rock, using some hardscaping is really helpful. I've seen too many rain gardens just end up weedy pits and then eventually get mown over and they almost disappear. But if there's like big boulders, there's rock lined edges, there's cues in the landscape that people can see and understand that like this is here, it's doing something, more likely to be maintained maybe, and maybe as well as more interpreted in the landscape as not just like a big wild weedy area. Some examples of how they can be integrated. This is the one here. We kind of went with the architectural design, very straight, clean edges, the primary colors, and we ran with that. We did like a linear design of the rain gardens. We integrate a lot of blue and red and yellow flowers into it. This is our installation. We had a great crew. Plant design. I wish I had more time to talk about this, but we definitely want a diversity of plants. Multi-layered, having both, I encourage trees, shrubs, grasses, flowers, ground covers, having all those layers present. The more variety above ground, the more root diversity you'll have below ground, which leads to more, water getting soaked up and water retention capacity. And then salt tolerant plants, especially if they're in a place where there's salt being applied in the winter. Hardy native plants. Whoops. Let's see. Oh wait, I'm going the wrong way. You might want taller, more flood tolerant plants on the bottom, more spreading, stabilizing, woody shrubs on the slopes to help stabilize and prevent erosion. They can do both wet and dry because they'll be flooded and they might also dry out. And then trees, maybe on the top, more on the top edge of the berm. Grasses or something with a lot of like thick biomass at the inlet, and that can help to dissipate flow. I'm gonna skip this. These are some of my favorite plants for rain gardens, trees, shrubs. I'm happy to share more of these if you'd like to have some ideas. But they're super hardy. They can, you know, withstand both dry and wet conditions, and don't require a lot of maintenance. You can also just seed a rain garden if you'd like to, with like a perennial and annual meadow mix. Can be a lot more cost effective. And that's all for now. Yeah, let's open it up to questions. These are more resources here, both the Vermont Rain Garden manuals, the Vermont Guide to Stormwater Management. I also recently redesigned a info sheet from the Lakewise program at Vermont DEC on rain gardens. So kind of a quick how-to in a few pages of like DIY rain garden. And then Rachel and I are teaching a landscape design fundamentals course, March 11th through 15th here at Yester Morrow. Let's open it up for questions. Thank you all so much.
I guess, just curious if there are efforts being done to, you know, look at ecosystem services or quantify the economic standpoint of like what this is doing. I think a lot of people here are on city street plan.
Yeah.
City planners like, how does this number work out or things of that?
Yeah, I find there's so many ecosystem services provided in the rain garden because I'm trying to think of all the different categories of ecosystem services, but there's like, you know, not only is there the water filtration, there's also like the carbon sequestration and the shade. And then I've gotten to be part of a few projects with like elementary schools and like talking about the cultural ecosystem services. There's so much that you can integrate learning and education and connecting with interpretive signs at the rain gardens and working with people to kind of connect people to what's happening in the watershed. And so that's big. I also focused on cultural ecosystem services in some of my research. So that's something I'm excited about. But yeah, there's just a lot of co-benefits. I also find that it can be hard to integrate naturalized areas into already built up urban areas. And this is a great way where you're layering so many ecosystem services that you can like steal a couple parking spaces maybe and put in a rain garden or bioretention system, and then layer on all these awesome benefits of like native plants and pollinator habitats, creating like whole systems. Like I always think about the cities that have been pretty successful at this, and they have bioretention like on every street or in every area. And you think about butterflies and bees who can then like travel through the city because there's all these islands that are connecting with native plants. And it's also with like the trees, or it can be simple street trees that have whole basins underground. You might not see them, but it's full of like filter media mix. And so that tree is creating so many co-benefits, shading, preventing this like urban heat island effect. But yeah, I think there's a lot of points to sell city planners on. Are there any ones you have like specifically thinking of that?
More broadly, as I'm looking at how monetarily minded, how the efforts there to quantify the money if somebody might want to speak that way.
There are a lot of people. Yeah, there are a lot of people who have tried to put monetary amounts. I can try to send you some papers, but yeah, there's definitely a lot of research out there that has done that. Yeah.
Who have you, okay, so like when you design a rain garden for a bank or an elementary school or something like that, who do you usually use as like the point person of like, okay, you are going to be responsible for the maintenance of this rain garden, let me educate you on this. Like, how do you keep that ball rolling for the success of the rain garden?
Yeah, it's a really challenging part of it all because they're kind of new infrastructure that require this like new set of maintenance. And so it's hard because, you know, sometimes there's only enough funding to like get the design and the installation in, but the more you can bring the maintenance, whoever's going to be overseeing the maintenance or actually maintaining it themselves, the earlier you can bring them into the design process, the better. And if they can be a part of that design process and maybe have great ideas about, you know, you don't want to design this like crazy biodiverse garden if no one is ever gonna like weed it or maintain it. Maybe like choosing a more simple plant design, a more simple plant palette so that it's kind of easier to maintain. Or like, yeah, I think working with understanding the maintenance capacity is a huge design part, like a design piece that you really have to think about. And yeah, there's like one rain garden. We're working with the maintenance person at this school district, and plantings, there just really isn't the maintenance capacity to maintain plantings. And so we're mostly just doing rock lined basins with some native grasses and some shrubs that require like little to no maintenance, but mostly just rock line, so they can kind of easily integrate it into their existing maintenance capacity. But it's also a good opportunity if you can bring in like local gardening clubs or people that are interested and want to be involved in the maintenance of this. It is hard though to kind of keep that momentum. Yeah, it's a challenge, but it's a really good thing to kind of be aware of. And I think just the best thing is bringing those people in as early on in the process as possible. Yeah.
What's the importance of round stone? I get the washed gravel, but seems like you were pretty adamant that stones be round or river stone.
Oh, they don't have to be. More of an aesthetic thing. Well, it depends. It is hard. I mean, it's hard to, if you don't have like that vacuum system to pull out sediment, like if you have the vacuum, bigger rock is better, because then you can like vacuuming the sediment up without sucking up all the rock. Typically though, to like fully do a, you know, clean out of the system, you have to like pull out all the rock, kind of get all the sediment, wash it out, or just like pull it out and then reinstall it. But more of an aesthetic thing.
So
Yeah.
in terms of like local materials you can use, anything crushed round stone, it doesn't have to be like a river stone.
No, it doesn't have to be a river stone. You want the rock to be big enough so that it doesn't like wash out itself. So if it's at like the inlet, and if it's too small of gravel, it might like wash out into the rain garden with high flows. So, but sometimes it can be good visually too to have like a variety of stone sizes. But the river rock just seems to be a bit more like for aesthetics. Yeah. But angular stone works great too. Yeah. Yeah, anything else?
Any questions online?
Oh, yeah.
Great, well,
Great.
thank you, Holly, very much.
Thank you all so much. I'm clapping for you all. You're a great audience.
I'm glad you played the class this spring too.
Yeah.
Well, thank you all for coming. We have, Sarah, 3 more or 4 more? The next 4 Wednesdays, we've got same time, same place, all lectures. So please come back, tell your friends, and we look forward to having you again. And have some refreshments.
Well, the next week, it's 305 and environmentalism.
Yes, and the next part,